Hey, this is Mr. Hendrickson, and this is your Conceptual Physics Bus Post Lab. The point of this video is to give you an idea of exactly what your physics instructors are looking for when you complete this lab, and really any other lab throughout the course of this year. Along the way, we will help you with some of the answers here, so do make sure your answers match mine. On the first part during the pre-lab, you were supposed to answer a set of questions to guide you towards the definition of speed. So, when given the speed of a car, what units do you usually use? That's, of course, miles per hour. In every other civilized and non-civilized, for that matter, country, what units are used? Well, all you had to do was a quick Google search and you would have found the answer is kilometers per hour. In both of these examples, miles per hour and kilometers per hour, the first word in both of those units is a measure of distance, of course, because kilometers and miles both measure distance. What does the term per mean in both of those? Miles per hour, kilometers per hour. Well, that of course means division, or to divide. And the last part, in miles per hour or kilometers per hour, of course, the hour is a measure of time. So that should get you thinking about what you are actually measuring and what speed truly represents. So let's talk about the lab. In the first part, you were supposed to determine what materials were needed to actually go ahead and take these measurements. Of course, you all decided eventually that you would need a meter stick and a timer. Hopefully, your physics instructor also provided some sort of sidewalk chalk to go ahead and take these measurements. When you took your measurements, you were supposed to create a data table. In all of our labs, if a data table is not provided, make sure you do use a straight edge, like a ruler, and a pencil to create the data table. For this data table, we wanted you to put the variables you were measuring across the top and the number of trials along the left-hand side. Your data table should look something like this. Your labels would go across the top, your trial labels would go across the left-hand side, and you would have a spot for 5 trials. So, the question here is, how do you record your 10 meters? How accurate and precise do these measurements need to be? So, in this case, you need to take a look at really how many significant figures you're recording. In the first example, 10 meters here, this 1 is your only significant figure. This is an estimated value. That means that the 10 spot is not known exactly. So, did you measure out 20 meters? Did you measure out 0 meters? Did you measure out 10 meters? If you are that uncertain, then you would record your value as just 10. In the second notation, 10 with a decimal spot, that tells us that the 1 spot, or the 0 here, is your final significant figure. That means the whole meter is unknown. This tells us that our estimate or our measurement is known to be somewhere in between 11 and 9 meters. This might be more accurate for us. This might be something that you choose to use, depending on how precise and accurate you are with your measurements. The final example here has the 10th of a meter as estimated, and this would be a measurement where you think you're off by, on the high side by 0.1 or on the low side by 0.1. So your measurement's somewhere in between, about 10.1 to 9.9 meters, somewhere in that range. If that's the case, then of course you would want to pick this measurement here. Make sure you talk over your measurements with your partners. Think about exactly what you did to measure out that 10 meters, and think about how you use the meter stick, which is only 1 meter, to do it. When you went ahead and actually recorded your values into the data table, what we were looking for here was your independent variable along the left-hand side and your dependent variable along the right-hand side. When you wrote in the actual variable, in this case time and distance, you need to make sure you always include the units as a label. So in this column here, you were measuring your time, which would have been in seconds. Along the right-hand side, you would have been measuring distance, which would have been in meters. And again, you would do that for all 5 trials. Once you record the unit in up here, you don't need to do it in these locations down below. As a quick aside, what's the difference between a dependent or independent variable? The independent variable is any variable that is completely independent or does not care at all or is not impacted at all by the other variable. In this case, think about what you measured. Many groups chose the same car. Many groups chose different distances. But the one thing that was always the same, no matter how fast the car would go, no matter how big the distance, would be time. Time always marches on. Time is completely independent of the car you chose, the distance the car was traveling. It does not matter. Time always moves on. And in this case, time would be the independent variable. So, in the next part, we wanted you to write the formula for speed. In this case, we were looking for you to write the word speed equals and then your mathematical equation, using, in this case, variables. Okay, so for your variables, what variables did you measure and how mathematically did you apply those variables? Really what we were looking for here, guys, was speed is equal to distance over time. Under that, we wanted you to write a quick explanation of how you knew the variables were in those positions. So in other words, how did you know it was distance over time? So talk about what you know about speed. Maybe talk also about what you learned in the pre-lab and what you did in the lab. In this section, you must use complete sentences. If you do not, you will not get full credit. All labs are expected for you to use full sentences. After you do this portion, you're going to go ahead and start calculating. Again, some of this might seem redundant, but these are all things you must do on your labs and tests for that matter. So, the first step in doing any calculation in physics is to write out the formula without any numbers at all. So in this case, we wanted you to write the formula again. Speed equals distance over time. After that's completed, you would go ahead and begin to insert numbers into that equation. So below the speed is equal to distance over time, you would write speed is equal to your distance, which would be 10 meters or 10.1 meters or whatever you measured for your team, divided by the time you measured, which would be your value in seconds. Speed is some numerical distance divided by some numerical time. Make sure you include the units here as well. So you would write the formula out, and then you would go ahead and plug in that distance in meters divided by that time in seconds. Once you have written that all out, then you would actually perform the calculation underneath. You would write speed equals and then the answer. Once you have your answer would of course be in a meter per second based on your measurements. But of course we want those measurements in kilometers per hour. So you would take your speed, write it in meters per second, and then we're going to do some Factorlabel. Remember, Factorlabel uses very simple division to cancel out units. So if this is a meter per second, we want to put meters on the bottom to cancel the meter and kilometers on the top to get kilometers. Now we would be in a kilometer per second. We need to get rid of those seconds. To do that, we know there's 3,600 seconds per hour, so we put seconds on top, which will cancel these seconds on the bottom. What we're left with is in 1 hour, or the unit of hour, on the bottom. Our final unit will then be kilometers per hour. Put that in your calculator, do the math, and you should have an answer. Make sure you think about it and double check that your answers actually make sense. Take a look at this speedometer here and look at the values listed on the inner circle. These might help give you an idea if your answer actually made sense. You do need to make sure you apply significant figures to all your calculations. If you're not sure about significant figures, please take a look at pages 7 through 10 in your Glenbard West Science Manual. This information will also show up in a quiz next week. Please review this information. Finally, you're going to make a chart that lists all of your data and your findings. What you'll want to do is go ahead and put the word speed at the top, trial number along the left-hand side, and insert those values into the chart. It should look something as simple as this. Do make sure you apply or show the calculation for one trial. I know you've already done it, but we want to see it again. So please show that work that you did on the previous page. Again, right next to this data table. Show the formula, show the numbers subbed into that formula, and then show the answer. Just like this. Then finally, finish off with a short statement of what speed is and how you go about calculating it. Again, in this section, make sure you do use complete sentences again. And then in the final portion, you'll want to discuss what errors occurred in this lab. What sort of things occurred in your measurements and in the process that would have led your team to get results that were not completely accurate. You are not allowed to say measurement error, you are not allowed to say calculation error, and you should never say human errors. You must be very specific in the process to describe exactly what occurred that would have given you inaccurate results. That's it for the lab. Make sure you've double-checked all of these questions and done them exactly the way we want, in the format we want. If you're still unsure of how to do this, please take your lab to your teacher and have them give you a hand. Thanks a lot.